Assalamualaikum warahmatullahi wabarakatuh, and good morning to all students. Today you are going to learn about periodic function. So what is the definition of periodic function? So periodic function is a function that repeats its values in regular intervals or periods. Okay, periodic function is a function. It's actually a function that repeats itself, repeats the same value, okay, in regular intervals or periods. Alright. So in this chapter Fourier series, you are going to learn how to write down a periodic function that can be represented in a series of sine and cosine function, because we already know that sine and cosine function are the most important examples which repeat over intervals of 2 pi radian. So we know that sine and cosine function are periodic functions. Okay, so I'm going to discuss one example here. We have a function of ft equals to t, where t is between -1 to 1. It's actually the first question in the sketching questions that you have done on Monday. Okay, so we're gonna have the plot of ft equals to t. So this is ft equals to t between the interval -1 to 1. Alright, so how can we expand it? How can we turn it into a periodic function? Okay, so I'm going to begin with, because in the definition it says that a function that repeats itself in regular periods. Okay, so first step is to determine the fundamental period. Alright, okay, so we have done the sketching of the function between -1 to 1. So in order to determine the fundamental period, we just need to find out what is the size of the interval. Okay, from -1 to 0, we know that the size of the interval is 1. Okay, from 0 to 1, also 1 unit. Alright, okay, so we can see that the fundamental period t is equals to 2. Okay, means that as in between two units, okay, between -1 to 1 is a one complete cycle. Okay, so in the period of t equals to 2, alright, the function is going to have the same sketch. I'm going to write down what is the definition of t. So t is fundamental period. So for one complete cycle. Alright, okay, so let's expand the function. Okay, I'm going to write down, I'm going to add ft plus 2 is equals to ft. So what does it mean? As t increases by 2 unit, because the fundamental period is 2, right? And we know that in between this period of 2, okay, the function is going to repeat itself. So ft plus 2, as t increases or decreases by 2 units, then it is equal to the same function as we have sketched between. Alright, now the function becomes a periodic function. So we have to sketch the function, we have to expand the sketching. Alright. Okay, so we have here from initially the function is from -1 to 1. So we have to expand it to until 3, right? Because over the interval t equals to 2, it's going to repeat itself. So as t increases by 2, okay, so 1 plus 2 is 3, -1 plus 2 is 1, 0 plus 2 is 2. So in between this interval, you can see that the function is going to repeat itself. Alright, okay, so if you want to expand further, So we have one complete cycle between t equals to 2. Okay, so we increase t by 2 units. So we have, this is 4, and the function is going to repeat itself. Alright, how can we expand it to the left? Alright, we're going to apply the same concept, 2 units. So now this is minus 3, in between we have minus 2. So this is 2 unit, negative 3 to negative 2 is 1 unit, negative 2 to negative 1 is 1 unit. So we're going to sketch the same function. So one complete cycle. Alright, so it's going to repeat the values, repeat the same sketch. Okay, and when you sketch it from negative infinity to infinity. Alright, so this is how you determine the fundamental period t. Okay, this is how you sketch a periodic function. This is what is the definition of periodic function. Okay, thank you so much for your attention. I'll give you a few questions of periodic functions. Okay, thank you so much. I'll see you in the next video.